Okay, the next example is an angular momentum problem. So very similar to regular momentum. We have our initial momentum at the start plus our impulse is equal to our final momentum of the system at the time. So in this case, our system is in this case simply going to just be the wheel here. Um, our system is the wheel, and we can imagine there's a force that is some sort of exerting some sort of torque on the system. So that would be external to the wheel. All right. So we have drawn here initially what is occurring, and then if we have a torque exerted in the same direction as the initial angular speed, it's going to increase its angular speed. It's just going to spin faster. It's already moving one way, you exert a torque in the same way, it's going to move faster. So angular momentum is very similar. We only have one object here, so we have the initial angular momentum L. L is the symbol for angular momentum, plus the angular impulse, which would be torque times time, very similar to linear impulse, except again, angular quantity, torque times time, instead of force, will equal its final angular momentum. So to recall, momentum is mass times velocity. The angular equivalents are rotational inertia times the initial angular speed plus the net torque times the time is equal to the angular momentum times the final velocity. So here we have everything labeled. We know initially that it has a rotational inertia of 1.5 and is rotating at 8 radians per second. The torque exerted is 5.5 Newton meters. So they were kind enough to give us that torque times 4 seconds, and that will equal 1.5 times the final angular speed. So here we have 12 plus 22 is equal to 1.5 times the final angular speed. We calculate the final angular speed, and we find out that the final angular velocity is 22.67 radians per second. And just to kind of rehash here, this is very similar to an impulse momentum problem where you have the initial momentum. There is an external impulse which will equal the final momentum. And it's the same process as we've seen before.